Good morning, friends. I, Dr. Devesh Bandil, Associate Professor, Suresh Gyan, Vihar University, Jaipur, Rajasthan, that is accredited by NAC A grade. Today, I will discuss about Heap data structure. Heap is the one of the data structure, and in this lecture, I will discuss about the Heap. First of all, I am sharing my screen. I hope you can see my screen. You know, there are so many data structures like your queue, graph, and today I will discuss about heap data structure. Before start the heap, I would like to discuss course outcome and objective of your data structure and algorithm. You know, your objectives or data structure and algorithm are to demonstrate the concept of your algorithm, to demonstrate the concept of your stack, to demonstrate the concept of your queue, linked list, graph, queue, stack, searching, and your sorting. And if we will discuss about the outcome of your data structure and algorithm, so you know there are so many outcomes of a data structure and algorithm. After studied the subject, student will able to how to write the algorithm, how to find the complexity of algorithm, how to write the stack implementation, how to write queue implementation, and also student will evolve with will able to concept of your graph, concept of your searching, concept of your sorting. And now in this lecture, I will discuss about the heap. I hope you can see my PPT. During this lecture, I will discuss about so many topics of your heap, like your object and outcome of this lecture. What is heap? What is minimum heap? What is maximum heap? How to write the algorithm for maximum heap construction, and also how to write the algorithm for maximum heap deletion. And first, I would like to discuss about object and outcome of this lecture. The objective of this lecture is to understand the concept of your heap. And after studying this lecture, student will able to how to construct the heap, how to construct the maximum heap, how to construct the minimum heap. And now I will discuss about what is heap. What is heap data structure? You know, your heap is a advanced tree based data structure. I had already discussed about the tree data structure in my previous lectures. That's why I think no need to discuss about the tree data structure. But I am giving the overview of your tree. You know, in your tree, there is a one root, and your all nodes are connected through the root, and your root will always placed and at your level 0, and you know your level will start from your top to bottom. Means first of all your level will start from your level 0, level 1, and level 2, and your always your root will placed at your level 0, and your remaining all nodes are connected from the root through its branches. That is your tree. And you know, when I am discussing about the heap, so your heap is your advanced tree based data structure and used to primarily for sorting and implementing priority queues. Your heap will be used for sorting and implementing priority queues. I think you know about the queue. You know your queue is based on your first in first out, that is your FIFO. If you are taking a ticket from the ticket window, if you are the first person who are stand at your first level in your queue, so obviously you will take the ticket first. That is your queue concept. And you know they are completely binary tree that have the following features. Every level is filled except the leaf nodes. You know about the leaf nodes. Leaf nodes are those nodes who have no any children. That is your leaf node. So every level is filled except the leaf node. You know, and I had already mentioned here, nodes without children are called the leaves. If your nodes are not having the any children, are called the leaves. And every node has a maximum of two children. There is the property कि every node has a maximum two children, and all the nodes are as far left as possible. The means that every child is to the left of his parent. These are the properties, these are the following features. They are complete binary tree that have the following features. As per I told, every level is filled except the leaf nodes. You know your leaf nodes are children are called the leaves. Every node has a maximum of two children. All the nodes are as so far left as possible. This means that every child is to the left of his parent. And you know, heap use the complete binary tree to avoid holes in the array. And you know about the array. Array is the where you will store the same data of items. A complete binary tree is a tree where each node has at most two children. You know your if we will talk about the complete binary tree, so your complete binary tree node has at least has at most two children, and the nodes at all levels are full. In your complete binary tree, there are two situations. First is that your every node has at most two children, and your all levels are so filled except the leaf nodes, which can be empty. So now if we will talk about the complete binary tree, so your complete binary tree will follow the following property. First property is that your node has at most two children, and your second property is that your all levels should be fill, and your third concept, your leaf node means you can accept the leaf node which can be empty. Heaps are built based on the heap property, which compare the parent node key with its your child node key. Okay, in your heap, you will compare the parent node key with your child node key. And if we will talk about the advantage and disadvantage of your heap, you know there are so many advantage of your heap. First advantage is that garbage collection runs on the heap memory to free the memory used by the object. And second advantage is that heap are flexible as memory can be allocated or removed in any order. This is the main advantage of your heap. Your heap are flexible as memory. Means if you will use the heap, so in your heap you can allocate the memory in your easy manner or removed in any order. And your variables can be accessed globally, and it help to find the minimum and greatest number. That is the another advantage of your heap. That there are four advantage of your heap. First is your garbage collection runs of the heap memory to free the memory used by the object. And second advantage is that heaps are flexible as memory can be allocated or removed in any order. And the third is that variables can be accessed globally. And fourth is that it helps to find the minimum and greatest number. These are the all advantage of your heap. And now I will discuss about the disadvantage of your heap. If we will compare to stack, a heap take more time to execute. This is the disadvantage of your heap. you know about the stack. Your stack is based on your last in first out. That is your LIFO. L for last, I for in, F for first, O for out. That is your last in first out. Because in your stack there is only one hand, and you will insert the item from this end, and also you will remove the item from this end. Okay, for example, in your stack, suppose if you are taking a CD box, and in your CD box, you will insert the CD from only one inside, and also you will delete the CD from only from the same end. So that's why your stack is based on your last in first out. There are some operations of your stack, like your push operation and your pop operation. you know Push operation, when you will insert the item in your stack, this is your push operation. And when you will delete the item from the stack, that is your pop operation. So now here I am talking about the disadvantage of your heap. If you will compare to stack, so your heap take more to time execute compared than your stack. And your memory management is more complicatedly in your heap memory, as it is used globally. you know your heap, it is used the globally. That's why your memory management is more complicated in your heap memory. Heaps generally take more time to compute. So these are the disadvantage of your heap. And if we will talk about the application of your heap data structure, there are so many applications of heap data structure, like your uh, heaps are efficient for finding the minimum or max element in your array. If you are taking an array, and in your array you want to find the minimum element, and also you want to find the maximum element. So you can find the minimum element and maximum element through the heap, and are useful in order to statistics and selection the algorithm. The time complexity of getting the minimum and maximum value from a heap, that is your one. This is the first application. As per I had discussed, through the heap you can find the minimum and maximum element into the array. And means from the array, if you want to find the minimum element and maximum element, that is the possible through the heap. And your priority queue are designed based on your heap data structure. If you want to design the priority data structure, priority queue, so you can design the priority queue through the help of based on your heap data structures. It takes log n time to insert and delete operation each element in the priority queue efficiently. That is the second application of your heap data structure. And third is your heap implemented priority queue are used in your popular algorithm, like your primes algorithm, the Shiktra algorithm, and your heap sort algorithm. These are the algorithm and your heap implemented priority queue are used in your popular algorithms. You know, as per I had told, heap implement priority queue are used in your popular algorithms like your Prims algorithm, Deshita algorithm, and your heap sort algorithm. And now I will talk about the essential operations of your heap. There are so many essential operations in your heap. First is your heapify. Through the heapify function, rearrange the elements in the heap to maintain the heap property. Means if you want to rearrange the elements in the heap to maintain the heap property, so you will use to heapify function. And insert an item to a heap. Means when you want to insert the item in your heap while maintaining the its heap property, you know you will maintain the all times of your heap property, either if you are insert the item in your heap, and either if you are rearranging the elements in your heap. And delete and also remove the an item from a heap, and execute return the value of an item and then deletes it from the heap. Okay, so that's the your extract operation. And if we will talk about the is empty operation, so in your is empty operation, boolean return true if boolean is empty and false it has a node. That is your is empty operation. And size, return the size of the heap. When you want to return the size of your heap, you will use the size operation. Get max, return the maximum value in a heap, you will use the get max function. And there are two types of your heap. First is your minimum heap and second is your max heap. If we will talk about the minimum heap, where the value of the root node is less than or equal to the either of its your children. That is your min heap. Means minimum heap. Means in your minimum heap, your the value of the root node is less than or equal to the either of its your children. Suppose I am taking the input like your 35, 33, 42, 10, 14, 19, 27, 42, 26, and your 31. And the key point of your minimum heap, where the value of the root node is less than or equal to the either of its your children. You can see here, this is your minimum heap. And here you can see your each parent node, your root node is less than from and from your children's, like your 10 is less than from your 14 and 19. Here your 10 is your root node and your 14 and 19 both are the child nodes. And 14 is less than from your 26 and 31. 19 is less than from your 42 and 27, and also 27 is less than from your 44 and 35, and your 31 is less. Okay, so here your all root node will less than from your children's. That this is your minimum heap. And your 31 is less than from your 33. Okay, so in this image, in the slide, you can see your all parent node, your all root node value are less than from your child node. And if we will talk about the maximum heap, I had told about the types of your heap. First heap is your mini heap, and second type of this is maximum heap, where the value of root node is greater than or equal to the either of its children. Your maximum heap is just a reverse of your minimum heap. In your maximum heap, where the value of the root node is greater than from your equal or either of your children, and whereas in your minimum heap the value of your root node is less than or equal to from the children node, from the children. And here I had draw the maximum heap as per above input. Your inputs are 35, 33, 42, 10, 14, 19, 27, 44, 26, and your 31. Okay, and as per the input, I had draw the maximum heap. you know Here your all root node, all parents node value is greater than from your child node. Your 42 is greater than from your 42 and 35. 42 is greater than from your 33 and 31. 35 is greater than from your 19 and 27, and your 31 is greater than from your 14, and your 33 is greater than from your 10 and 26. So here, through this property, you can draw the minimum heat, and also you can draw the maximum heat. And also you will write the maximum heap construction algorithm. We shall use the same example to demonstrate how a maximum heap is created. I had already discussed about how to your maximum heap is created. In your maximum heap, your root value is greater than or equal to the from your its children. And the procedure to create minimum heap is similar, but we go for the minimum value instead of your maximum value. When I'm talking about your maximum heap, so in your maximum heap construction, your root value always greater than or equal to the children's node. And where is your node? If we will talk about your minimum heap, so in your minimum heap, your root value is less than or equal to from your its children. We are going to drive an algorithm for max heap by inserting one element at a time. At any point of time, heap must maintain its property. While insertion, we will assume that we are inserting a node in a already heapified tree. You know, These are the all steps of your algorithm. You know your algorithm is only a step by step instructions. You first of all you will complete the instruction, after that you will complete the instruction, after that you will complete this instruction. So in your step first, create a new node at the end of heap. First of all you will create a node at your end of heap. And step 2, assign a new value to the node. First you have to create a node at your end of heap, and after that you have to assign the value. And in your step third, compare the value of this child node with its parent. You will take the child node, so always you will compare the value of your child node with its parent. Because if you are constructing a maximum heap, so in your maximum heap your parent value is always greater than or equal to from the children's. And if you are drawing making a minimum heap, so in your minimum heap always your roots value is less than or equal to the from the child value. That's why in your step third, if you are constructing a maximum heap, so you will compare the value of the child node with its your parent. And in your step 4, if value is your of parent is less than from your child, then swap them. Okay. And about the concept of your swap means if you are taking the two variable, and if your first variable will take the value of your second variable, and the second variable will take the value of your first variable, so that is your swapping. And when you will apply the swapping, so your swapping is possible through two way. First way is that you can take the extra variable for the swapping, and also in your second way you can swap without the extra variable. If you are taking a extra variable, suppose like your extra variable is your temp variable, and if you are having a two variable like your a and b, and you want to write the concept for your swapping, so in your first statement you will write the temp assignment operator a. And when your this statement will be execute, the value of a variable will assign to your temp variable. And in your second statement you will write the a assignment operator v. And when your this statement will be execute, the value of v will assign into your a. And in your third statement you will write b assignment operator c, means your temp variable will be assigned into your v variable. After execution of these three statements, your variables value have to be swapped. Okay. And I have so many times discussed about your swapping. And in your step 5, repeat step third and fourth until he property maintain. Okay, so these are the 5 steps, and your all steps are in your sequential fashion. In your first step you will create a node at the end of the heap. After that, in your second step, assign the new value to the node. And third step, compare the value of this child with its parent. In your step 4, if value is parent is less than child, then swap them. And in your step 5, you will repeat again to again third and fourth step until heap your proper and until heap property will be hold. There is the important instructions for a maximum heap. In your minimum heap construction algorithm, we accept the value of the parent node to be less than that of the child node. And max heap deletion algorithm. In your max heap deletion algorithm, you will write the algorithm to delete from the max heap. Deletion in maximum heap or minimum heap always happen at to the root to remove the maximum or minimum value. And when you will write the algorithm for your max heap deletion algorithm, in your step first remove the root node. In your step first, you will remove the root node. And in your step two, move the last element uh, of last level to root. Okay. And in your third step, compare the value of this child node with its parent. Compare the value of your child node with its parent. If the value is parent less than your child, so then swap them. Because in your, if you are constructing a maximum heap, so in your maximum heap, your parent node value should be greater than or equal to the from the child node. Suppose your parent node value is less than from your child node, that time you will apply the swapping. And in your step 5, fifth, repeat step third and fourth until heap property hold. So these are the all algorithms when you will apply the max heap deletion algorithm. Okay. And now, you know, here I had discussed about the so many questions, and in a maxi heap, as per I had told, that the time of your end of this lecture, I will discuss about so many questions of your heap. In a max heap, element with the greatest key is always in which node? Your leaf node, your first node of left subtree, root node, and your first node of your right subtree. Here I am talking about your maximum heap. And after started this lecture about your max heap, in your max heap, your parent node value should be greater than or equal to your child nodes. So as per your question, in a max heap, element with the greatest key is always in which node? Leaf node, first node at of left subtree, root node, first node of your right subtree. Your answer will be the C, that is your root node. Means in a max heap, element with the greatest key is always in which the node, that is your root node. That's why your answer will be your C. Heap exhibits the property of a binary tree, true or false. So your answer will be A. Heap exhibits the property of your binary tree. And what is the complexity of adding an element to the heap? When you are adding the element in your heap, so that time what is the complexity of adding element to the heap? Your options are log n, your h, your log n and oh, and your n. Your answer will be your C, that is your log n and oh. And the worst case complexity of deleting any arbitrary node value element from heap is log n, log n, and your n square. Your answer will be your log n. When you will deleting the element, deleting the node value element from the heap, that time the worst case complexity is that you're in log n. Heap can be used as priority queue, stack, decreasing order array, and your normal array. I had already told about that. Heap can be used as your priority queue. Your priority queue is the application of your heap. That's why your heap can be used as the priority queue. And a array consists of your n elements. Suppose if you are having a array and you are taking the n elements, we want to create a heap using the element, and you want to create a heap using this element. The time complexity of building a heap will be in order of, first option is that your n multiply n log n multiply log n multiply n, and your n multiply log n. So your answer will be your n log n. So when if you are consist of your if you are taking an array of your n elements and you want to create a heap using these elements, the time complexity of building a heap will be in order of your n log n. And here is the question for your post order traversal and pre order and in order traversal. Here I had mentioned a tree, and your suppose you want to find the in order traversal. Okay, in your in order traversal of a tree, first of all you will visit the root node. After that you will visit the left node. After that you will visit the right node. So in your in order traversal, always you will visit your first node. Always you will visit the root node, left node, and your right node, left subtree and your right subtree. And in your another tree you can also find the traversal. Suppose right level order traversal.